Welcome everybody to today's math topic, solving single-step equations. Now this is going to be a 1 out of 3 part video where we go from single-step equations into two-step equations and then on to multi-step equations. This is a very highly important skill set to learn in algebra as we're going to see these types of problems over and over again. When solving equations, we oftentimes have variables which represents an unknown value. We can use the other values around it along with some orders of operation to find out what that value is. So in this video I've pulled together the 5 most common single-step equation examples that you might run into. Let's go ahead and get started. At this point I would love for you to stop the video, grab a sheet of paper, write these down, come back to the video and we'll work through them together. Alright, great. So the first thing we want to do when solving an equation is to locate our variable. In this equation x plus 5 equals negative 17, we have our variable here on the left side of the equation. If it helps, you can underline it, draw a box around it, whatever makes you feel comfortable. But what we're basically trying to do is keep this variable to one side of the equation and have all of our other values on the right side. So after we locate our variable, our next step is to find out, are there any additions or subtractions going on in the problem next to our variable? Here we have a plus 5. So we know that we have a set of addition going on the left side of our equation that we need to get rid of. In order for us to do this, we can subtract 5 from both sides. Doing the opposite of our operation, we're able to eliminate this value here and place it on the other side of our equation. So, being that there was nothing done with our x, we can immediately drop that down. Here we have plus 5 minus 5. This is going to give us 0. You don't have to write a plus or minus 0, but for this example I'll place it there so we can see what's going on. Our equal sign will immediately drop down, and then we can evaluate negative 17 minus 5, which gives us negative 22. And now we're finished. We have x without the plus 0 equals negative 22. So if we were to plug negative 22 into our value for x, I'll do this in a different color, we would have negative 22 plus 5, and that does indeed equal negative 17. So here we can safely say that to make this equation true, this statement true, x needs to be negative 22. Alright, let's try this next example. Here we have negative 15 equals x minus 3. So our variable this time is on the right side, and that's perfectly fine. It can be on either side of the equation. So remember, after finding our variable, we want to see, are there any additions or subtractions before we look for any multiplication or division. In this case we have a x minus 3, so like on the other problem we need to do the opposite of that operation with this value here, so they can essentially cross themselves out, equaling 0 like we did on the last one. Then we can start dropping down our values. But remember, anything that you do to one side of the equation, you must do to the other side of the equation. So, we can either work from right to left or work from left to right. In this case, I'll go left to right. We have a negative 15 plus 3, which is going to give us a negative 12. My equal sign can drop down, and my x can drop down. So now I have negative 12 equals x, which we can also write as x equals negative 12. And we're finished. Alright, if you need to catch up and copy all this down, go ahead and pause the video and come back for the next example. So this next example on our left says negative 3x equals 19. And what this is telling us is that we're taking a negative 3, multiplying it by x, and that's going to equal 19. So the first thing we need to do is isolate our variable, I'm going to put a box this time because there's a good rule of thumb that anytime we have a value in front of our variable, which is also known as a coefficient, and we're trying to find the value for that variable, whatever it is you're trying to keep, in this case we're trying to keep x, you want to divide both sides by what's next to it. So we're going to divide both sides by -3. Now here our -3's can go ahead and cancel, which leaves us with just our x. Our x will go ahead and drop down, our equal sign drops down, and then we have a prime number, 19, over -3. Now we could divide that out on the calculator and come up with a decimal, but -19/3 is a good enough representation for our answer. So we can box that up. In this next example, we have our variable on top of a 3 in a fraction set equal to 7. So this problem requires us to do what we call clearing the fraction. And in order for us to do that, this operation here is division, so we're going to do the exact opposite, which is multiplication. We're going to multiply both sides by 3. Here I use a set of parentheses around my 3 to indicate multiplication, and I place it near the top of my fraction. The reason I do this is because 3 is the same thing as 3 over 1, which if we multiply across the top, we would have 3y, and we multiply across the bottom would give us 3. Our 3's here would cancel, leaving us with just y. So going back, without writing all of this out, we can just say that we cancel our 3's out here, leaving y to drop down safely by itself. My equal sign will drop down, and now I have 7 times 3, which is going to give me 21. And that's finished. Y equals 21. Alright, so we have one more example. And now you're probably asking yourself, why do I have it written down on both sides of the screen? Well, for this example, there's actually 2 different ways you can do it, one of which will require an additional step, and one kind of streamlines everything into just one step itself. So like the last problem, we had a fraction, but here our fraction is in front of the variable. This is saying -3/5 times a is going to give us 27. So, like the last problem, we can multiply by the denominator. I'm going to multiply both sides by 5. My 5's will cancel out. This is going to leave me with a -3a. My equal sign can come down, and then I get 27 times 5. That's going to give me 135. So now I have a next to a -3, and I believe if you go back 2 examples, this is the type we had, where we're going to end up dividing both sides by a -3. Remember, when solving for our variable, we need our variable to be positive. So I'll divide this by a -3. My a will drop down, my equal sign will drop down. 135 divided by -3 is going to give me a -45. And that would be finished. So as you can see there, we did it, in 2 steps, whereas on the right, I'm going to introduce you to something called multiplying by the reciprocal. And if we remember what the reciprocal is, it's just taking our fraction and reversing the numbers. So instead of a -3/5, I would have a -5/3. And remember, I'll do this to both sides, so I'll have a -5/3. And in this case, our negatives would cancel out, our 5's would cancel out, our 3's would cancel out, and then my a would be able to drop down by itself. My equal sign can come down, and then now here I have 27 times -5, which gives me a -135. I'm going to put that over my 3, and that's the same answer I have over here, -45. So here we were able to do it in a little more cleaned up fashion, a little bit less writing, and kind of get there a little quicker. So whichever example works best for you, go ahead and do those. Alright, so now I have a few examples that I would like for you to work on your own. Go ahead and pause the video here, write both of these down, try them, come back to the video, and we'll work through them together. Alright, great. So this first example is like the one we just finished working through in our teacher example. And here I'm going to do multiplying by the reciprocal. So I'm going to multiply both sides by 3/2. My 3's will cancel, my 2's will cancel. I'll put my 3/2 over here. I'm going to go ahead and drop my x down. My equal sign comes down. I'm going to get 8 times 3, which is 24. I'm going to put that over the 2. And if I want to simplify this, 24 divided by 2 is going to give me 12. Alright, let's look at this next one. I have 15 equals 3x. I want to isolate my variable to this side. I have a 3 next to it, so I'll go ahead and divide both sides by positive 3. 15 divided by 3 will give me 5. My equal sign comes down. My 3's cancel. My x comes down. I have 5 equals x. I like to write it as x equals 5. And then I put my box around it. Excellent. I hope you guys got the same answer. Let's move on to 2 more. Alright, go ahead and pause the video here. Write these down, work through them. Come back and see if you got the answer correct. So here I have a 4 in my denominator. I'm trying to keep my x. I'll multiply both sides by a 4. My 4's will cancel. My x will come down. My equal sign comes down. 5 times 4 gives me 20. And I have x equals 20. Alright, this next one. I have 5 plus x equals 13. So here I have a positive 5 with a set of addition. So I want to get rid of this 5 here by subtracting 5 from both sides. My x comes down. My equal sign comes down. I evaluate 13 minus 5, and that's going to give me positive 8. Alright, moving along. I have one more left for us to do. Pause the video here, write this one down, and then we'll work through it. So this one might look a little bit different than the example that I gave you, in that we have a negative in front of our variable. But that's fine. This is a really easy fix. So we have a set of addition here. We have plus 12. So we want to get rid of this plus 12 by subtracting 12 from both sides. So we didn't do anything with our x yet, so our negative x will come down as it is. 12 minus 12 is 0. These cancel out. Our equal sign comes down. We have 4 minus 12. That's going to give us a negative 8. Now we have negative x equals negative 8. We want to keep x positive in order to find out what its value is. So we need to get rid of the negative that's attached to it. This can also be written as negative 1 times x equals negative 8. So in order to get rid of this negative 1, we can do one of two things. We can either multiply both sides by negative 1, or we can divide both sides by negative 1. I'm more comfortable with dividing, so I'm going to divide both sides by negative 1. So now my x will come down as these negative 1's cancel. My equal sign comes down. I have a negative 8 over a negative 1. A negative divided by a negative is going to give me a positive, and I am left with x equals 8. I can put my box around this one, and I am done. Alright, so that's it for this first video. Today's math topic, solving single-step equations. I wish you the best of luck.